This video demonstrates Ironwood Electronics package on package socket assembly and testing. The socket comes with various components. The main component is the socket assembly with the elastomer installed on it. It is also comes with the bottom side insulation and a back plate, sometimes called as a stiffener plate. It comes with the hex tools, comes with the necessary hardware. It also comes with the extra top side memory elastomer in a separate bag. Right now I removed it from the bag and placed it here. It also comes up with the spacer. So this side I put the test components. The green big board is the daisy chain test component, which has the daisy chain pattern for the processor. Here is a processor chip which has the counter daisy chain on it. When the socket is assembled, we will place the daisy chain that connects this thing. On the top of the processor there is a pattern for memory, and I have a separate memory chip that connects these two. So when it is assembled, we will test the whole sequence. So the first step in assembling this is make sure your target board is clean from debris. Then the socket has an alignment pin, two big alignment pins that goes into the target board like this. It can go in only one way because there is a big alignment pin and a small alignment pin that lines up. Then we have to use this insulation plate because there will be components on the back side of the board. So line up this insulation plate in the same way. In this particular case we don't have those components because it's just a test board. So you line up all these four hardwares and then tighten them. We can specify a specific torque for it, but the idea being that it is evenly tightened, less than 1 inch-pound torque or something like that. So when the socket is assembled onto the target board, it will be looking like this. You can open the socket out. Then the first thing you wanted to verify it, make sure the A1 corner, which is marked in here. Now the processor with the A1 corner is also marked here. You can just use a tweezer or sometimes a vacuum pen to take the A1 corner and match the A1 corner. Also, it's a good idea to verify, make sure under the microscope everything lines up. Then the next important thing is to place the top side elastomer into it. It would be a good idea not to grab them with the when you grab them with a sharp material, do not puncture it. In this elastomer, the key thing is there is a protruded button on one side and flush on the top side. So you wanted to make sure the protruded button is always on the bottom side. That is what going to go make the contact on the pads which are on the top side of the processor. If it is too complicated, look them up under the scope. It will be very obvious. Once when the buttons are on the bottom side, you also wanted to make sure that there is a, even though this is a symmetric, it is a symmetric version, We always put a little chamfer in it that could be easily line up for the A1 corner. So right now we are placing this A1 corner, placing the part. So it's also very important to make sure that it sits inside the pocket properly. Check under the scope. Then the additional one we are going to do was we provide a spacer. This is to accommodate the gap, the cavity in the elastomer center area. So it is placed like this, the spacer. Now everything is assembled. Now the top component, which is the memory, also has the A1 corner. You grab that, place them on it in the center properly. Once when that is placed, then you close and then you can turn it. So you close the screws. Because it is a elastomer, we recommend a torque to compress the two packages evenly onto the target board. This torque driver is an adjustable torque driver. Right now it is set up at 5 inch-pounds of torque. So what it does is it applies the 5 inch-pounds, and then after that it starts slipping. So you can see that the tool is applied and then it slips. So now 5 inch-pounds of torque is applied to the socket. So we are going to verify with this multimeter whether the whole socket is working for 100% continuity. So we have a test points here which shows from a start to end. So I am probing that, and the meter shows about 16 ohms. That is the total resistance for the complete daisy chain of the bottom processor and the memory, 168 pin memory. So the total pin count is 718. So for 16 ohms it brings down to 25 milliohms per contact, and that is how the POP socket is tested. Thank you.